Fellow mathematicians, let's take a look at an example applying the ratio test where the work gets a little bit messier. As always, we're going to start by identifying the term a sub n, which is the entire term of our infinite series. This one's a little bit more complicated, n plus 1 times 3, and the exponent on that is 2n plus 1. That's going to be where some of the extra work comes in, so we'll take our time and be careful with that. And in the denominator we have 5 to the n. All right, we know what to do from here. We're going to increment, replace all n's with n plus 1. And first, let's deal with the part in parentheses. Replacing n with n plus 1, we'll get n plus 1 plus 1. We can simplify that to n plus 2. All right, I'm not going to try to do too much work at once. I'm literally just going to replace that n in the exponent of 3 with n plus 1, and I'm going to use parentheses. So we'll write that as 3 raised to the 2 times n plus 1 plus 1. And then in the denominator, we're going to have 5 raised to the n plus 1. All right, now there's some simple work that we can do. We can distribute that 2 basically through the parentheses. It looks like we're going to get that as 2n plus 2. And then we have the plus 1. And it looks like we can simplify the exponent of 3 as 2n plus 3. And I'm also going to apply the exponent trick, splitting up 5 to the n plus 1 as well. So let's go ahead and make use of both those. We're going to have n plus 2 times now 3 to that power 2n plus 3. And I'll write that denominator as 5 to the n times 5 to the 1, or 5. All right, now we could go directly to taking the ratio of a sub n plus 1 divided by a sub n, and you might see that the 5 to the n's would cancel out. But what about those powers of 3? 3 to the 2n plus 1 and 3 to the 2n plus 3. We can also apply our exponent trick to those terms as well. Let's do it first here. So I'm going to split up 3 to the 2n plus 1. I'm going to write that as 3 to the 2n times 3 to the 1, or 3. We're not incrementing, we're just applying the exponent trick to that power of 3. And I'm going to do the same thing with a sub n plus 1. Let me go ahead and apply the exponent trick to that power of 3. We'll keep the n plus 2 there, but we'll write that now as 3 to the 2n times 3 to the third power. All right, and that should allow us to cancel a lot of terms out when we take the ratio of a sub n plus 1 divided by this version of a sub n. So let's get to the work on calculating the absolute value of the ratio. All right, so we're going to start with a sub n plus 1 in this fully simplified version here. And again, take your time. We have that as n plus 2 times 3 to the 2n times 3 cubed divided by 5 to the n times 5. And since we're dividing by a sub n, which is a fraction, we're going to multiply by the reciprocal. And be careful, we're using this version for a sub n, where we split up, using our exponent trick, 3 to the 2n plus 1. All right, divide by a sub n, multiply by that reciprocal. We're going to multiply now by 5 to the n divided by n plus 1 times 3 to the 2n times 3. And we should find that a lot of terms cancel out between the numerators and denominators. First, we can cancel the 5 to the n's out, cancel the 3 to the 2n powers out, and we can even go a little bit further and cancel 1 power of 3 out. Since we're dividing by 3 and we have 3 cubed, looks like we're going to be left with 3 squared. Now, let's go ahead and write down what we get. We're not taking a limit yet. We're just simplifying this absolute value of the ratio. And all your powers here are going to be positive. Your values of n go from 1 to infinity. N plus 2 and n plus 1 will be positive. So the absolute value won't matter here, since all the quantities inside are going to be positive. And it looks like what we're left with is 3 squared, so 9, but times n plus 2. And in your denominator, we have a factor of 5 times n plus 1. All right, and here we can now take the limit of that and calculate L with the ratio test. The limit as n goes to infinity of the absolute value of the ratio. And that comes out to calculating limit as n goes to infinity of this 9 times n plus 2 divided by 5 times n plus 1. Now this one, you can go through and apply L'Hopital's rule. You might be able to recognize that your powers of n in the numerator and denominator are equal. So the limit is going to come out to the ratio of the leading coefficients, 9 over 5. But definitely apply L'Hopital's rule to get full credit. And what you'll find here is that the limit comes out to 9 over 5. And we do reach a conclusion here with the ratio test. And the conclusion is, since that is greater than 1, our infinite series is divergent. And there we go. We reach a conclusion with the ratio test. And the work here, a little bit more complicated since we had a complicated power of 3. Even changing that from 3 to the n to here, 3 to the 2n plus 1, that makes it a little bit more work and everything we went through to simplify that. Hopefully this problem helped you out. If it did, support the channel, like and subscribe.